Okay, 3.4. Matter and 3.4 energy. Energy makes objects moved, and it's defined as the ability to do work. Kinetic energy is the energy of motion. Examples are swimming, water flowing over a dam, or working out. Potential energy is energy stored for use at a later time. It can be influenced by position or chemical composition of a substance. So some molecules store energy, like we think of glucose and fat, and ATP is the energy currency. That's potential energy. So potential energy could be gravitational, or it could be energy in a spring. Identify the energy in each example as potential or kinetic. Rollerblading. Well, that would be kinetic. A peanut butter and jelly sandwich, potential. That's fuel. Mowing the lawn, kinetic. Gasoline in the tank, potential. Heat and energy. Heat is the energy associated with the movement of particles. The faster the particles move, the greater the heat or the thermal energy of the substance. Given an ice cube, as heat is added, the blank molecules are moving slowly, increase their motion. Eventually they have enough energy to change the ice cube from a solid to a liquid. It's important to point out that energy and temperature are not the same. Remember from the previous section that temperature has units, for our purposes, degrees Celsius or Kelvin. The units of energy, and temperature tells you about flow of energy, but it's not the same as energy. So the units of energy that you're probably most familiar with are calories or kilocalories. And there is also the joule or kilojoules. So 1 kilojoule is 10 to the third joules. Likewise, 1 kcal is 10 to the third calories. It's worth noting that 1 kcal is often written as 1 capital CAL calorie on food labels. So when you see something that says it's 100 calories on a food package, it's actually 100,000. A calorie is defined as the amount of energy needed to raise the temperature of water by of 1 gram of water by 1 degree C. So calorie. So it takes 1 gram of water, increases the temperature by 1 degree Celsius. There's a comparison of different energies for different purposes. So energy used for sleep, 10 to the 5th. Energy radiated by the sun in 1 second, 10 to the 26th. How many calories are obtained from a pat of butter if it provides 150 joules of energy when metabolized? 150 joules, it's 4.18 joules per 1 calorie. That's actually the conversion. 1 calorie is 4.18 joules. So I've taken this equivalence and turned it into a conversion factor. And because I have joules in the numerator here, I need it in the denominator there. So if I take 150 joules and divide it by 4.18 joules in 1 calorie, I get 35.88 calories, because the joules cancel. And because I am starting with 2 sig figs, I can really only have 2 sig figs in my answer, so the answer is C. Okay, so that's all. Working through that, you can look at it slowly. Energy and nutrition. 1 hour of swimming uses 2,100 kilojoules of energy. Calorimeters. These are devices that are used to measure the calorie content of various things. Nutritionists use bomb calorimeters to burn food, and they look at the amount of heat that comes off. So there'll be a diagram, or I think a picture of one. Yeah. So here is a calorimeter. Your food sample. Food sample is in here. This is a chamber where the food gets burned in the presence of oxygen. And then surrounding that is water. And so what happens is as the food burns, heat leaves the compartment and enters the surroundings. And what happens is the temperature of the water increases. And because we know how many calories it takes to raise 1 gram of water by a degree C, we can actually calculate the amount of heat that's created by this food and enters the burning of the food and enters the calorimeter. On food labels, energy is shown in nutritional calories, also written with a capital C. In other countries, you can actually see kilojoules too. I think I've seen kilojoules in Mexico. The caloric energy of value for 1 gram of food can be actually broken down and identified by its molecule type. So carbohydrates contain 4 kilocalories per gram and 17 kilojoules per gram. So if you just take this number and multiply it by 4.18, you'll get that one. Fats are more calorie dense. They have that's not the same as physical density, but they have more kcals per gram. And so a fat has 9 kilocalories per gram, or 38 kilojoules. Proteins are similar to carbohydrates with 4 kilocalories per gram. So if you know how many grams of carbohydrate, fat, and protein are in a food, you can calculate its caloric content. And here's a bunch of examples. So notice that a baked potato has 23 grams of carbohydrates and 3 grams of protein. So you would take 23 times 4 kcals per gram and also 3 times 4 kcals per gram and add those, and that would give you 100 kcals. So one thing you might be asked to do is I could give you, say for example, the nutritional content of beef. It's 14 grams of fat and 22 grams of protein. And so you would multiply this one by 9 because it's 9 kcals per gram, and 22 times 4 to get the total number of calories in 3 ounces of ground beef. So here's an example. A cup of whole milk contains 13 grams of carbohydrate, 9 grams of fat, and 9 grams of protein. How many kilocalories does a cup of whole milk contain? So I'd say 13 grams of carbs times 4 kcals per gram for carbohydrates. And then I would add it to 9 grams of fat. But fat, we know, contains 9 kcals per gram. And then we would add also the calories from protein, 9 grams of protein times 4 kcals per gram. So this will be 36. That will be 81. This one will be 52. And so when we add them all up, it should be. And that shows you how to work it out. Oops, where's the answer? Okay, well, I'm just gonna let me go ahead and add them in front of you. So I get 52 plus 81 plus 36. I get 169 kcals. They are keeping 2 sig figs. I would actually argue that you could keep the third because the decimal places we have numbers in all of the ones places, but you only have. Okay. Chemistry linked to weight loss. The number of kcals or kjoules needed in the daily diet depends on gender, age, and level of physical activity. And so I always sort of take offense at this slide because they have, for women from 19 to 30, you should have about 2,100 kilocalories of energy per day. If you're moderately active, 2,400. 31 to age 50, 2,000 if you are moderately active, 2,200 if you're highly active. Okay, so I happen to be off this chart. What happens if you're 56? No calories? Anyway, it's sort of interesting to look at this. Then they have the calories usage associated with various activities, and running, not surprisingly, is one of the ones that burns the most calories per hour. Okay, specific heat. The high specific heat of water keeps the temperature moderates temperature in the air. This looks like Brazil to me. Okay, specific heat is different for different substances. It's the amount of heat that raises the temperature of exactly 1 gram of a substance by 1 calorie. Oh, I need to have the units here. I would say these are calories per gram degrees C. This one must be calories. This one must be joules. So the units are calories per gram degree C or joules per gram degree C. And so you'll see that aluminum is 0.24, silver is 0.125 or 0.0562. By comparison, liquids have higher specific heats. So whereas aluminum's 0.214, ammonia is double that, and water is actually almost 5 times that. So water has a very high heat capacity. Okay, when the ocean cools, the surrounding air does what? It's going to warm. Sand in the desert is hot in the day and cool at night. Sand must have a high specific heat or a low specific heat. Because it cools off quickly, it has a low specific heat. Okay. So this is how we use specific heat. The equation as I'm used to looking at it is Q stands for heat, and that is equal to mass times the change in temperature times the specific heat, which they abbreviate SH. I will tend to use C as for specific heat. That's a more common abbreviation. I think it's also easier to read. So Q, which is heat, that can have units of calories or joules, or kilocalories or kilojoules. M must be in grams, that's the mass. Delta T is going to be in Celsius, and it's always the final temperature minus the initial temperature in degrees C. And then specific heat is either joules or calories per gram degrees C. So if you look at this, if I put in all the units, I'm going to put in grams for mass, degrees C for the change in temperature, because 90 degrees C minus 60 degrees C gives you 30 degrees C, and the units are degrees Celsius. And then the units for specific heat, I can pick either calories or joules, but I just have to be consistent. Let's do calories per gram degrees C. What we're solving for is going to have the same units of energy as the units of specific heat. So let's look. The grams cancel, the degrees C cancel, and so what we are left with are calories, and that is the correct unit for heat. So here's a question. What is the specific heat if 24.8 grams of metal absorbs 275 joules and the temperature rises from, where's all the, unfortunately it's not giving me the temperature rise. Let's say that, I guess we need to know this.